My name is Joan, and today I'm going to be discussing my research project, investigating the effect of the HAP1-mediated L-asparaginase resistance mechanism on mitochondrial calcium levels in leukemic cell lines. L-asparaginase is a crucial drug in the treatment of acute lymphoblastic leukemia, a common childhood cancer. While it is effective, a portion of patients develop resistance and relapse, often with poorer prognoses. Thus, it is important to investigate mechanisms of L-asparaginase resistance in order to improve patient outcome. Previous research characterized the mechanism of L-asparaginase resistance caused by the loss of the gene HAP1, which prevents the formation of the IP3R HAP1 Huntington ternary complex. Normally, this complex allows calcium to be released from the endoplasmic reticulum upon treatment with L-asparaginase and is thought to be responsible for an intracellular increase in calcium which causes cell apoptosis. The HAP1 depleted cells are on the right column of each figure. This data from the previous study shows that when HAP1 depleted cells were treated with L-asparaginase, they released less calcium from the ER and had lower intracellular calcium levels than the controls, thus preventing leukemic cell death and causing resistance to L-asparaginase. The objective of my research is to observe the effect of L-asparaginase treatment on wild-type and HAP1-depleted leukemic cell lines by measuring mitochondrial calcium levels and MPTP opening, with the goal of deducing a relationship with ER calcium release and intracellular calcium levels. In order to fulfill this objective, I measured mitochondrial calcium and observed MPTP opening, and compared my findings with previous research about ER and intracellular calcium. Just to briefly summarize the methods, two groups of SEM cells were used in this project: control cells infected with an empty PRS vector, and HAP1 depleted cells infected with a retrovirus carrying PRS SHAP1. ER calcium and mitochondrial calcium transients were measured through single-cell imaging, and MPTP opening was measured using flow cytometry. A Western blot was done to compare the expression of HAP1 in the cells. GAPDH was used as a loading control, so by plotting the ratio of HAP1 to GAPDH band intensity, it demonstrates HAP1 depletion in the PRS SHAP1 cells and not the control cells. One of the main goals of this experiment was to identify a relationship between ER calcium release and mitochondrial calcium uptake. The dark line above each graph signifies when L-asparaginase treatment occurred. In the control cells, ER calcium release and mitochondrial calcium uptake were observed. As such, it appears that uptake may occur through the mitochondria-associated ER membrane complex. To support a connection between mitochondrial calcium uptake and increased intracellular calcium, we examined the opening of the mitochondrial permeability transition pore, known as the MPTP, in response to L-asparaginase treatment. Increased mitochondrial calcium levels can cause the MPTP to open, which induces mitochondrial calcium to leave. This increases intracellular calcium levels and leads to apoptosis. SEM cells were loaded with calcine and cobalt chloride. Cobalt chloride quenches the fluorescence signal when the MPTP is open, resulting in a left shift on the graph. We found that in the control cells, MPTP opening was quite significant, while the HAP1 depleted cells did not display MPTP opening. This demonstrated that HAP1 prevents MPTP opening and presumably also prevents leukemic cell death. Through this project, new data was gathered that supports previous studies, the overarching goal being to gain a deeper understanding of the HAP1-mediated L-asparaginase resistance mechanism. We were able to link mitochondrial calcium levels to previous ER and intracellular calcium data. Overall, we observed that HAP1 loss results in reduced mitochondrial calcium uptake, which in turn causes reduced MPTP opening. Although a link between ER, mitochondria, and intracellular calcium was found, the relationship to apoptosis still needs to be validated. More repetitions of this experiment would be needed to reproduce these results. This data has applications in cancer research, specifically with regards to L-asparaginase resistance mechanisms. Potential implications include effective cures for HAP1 deficient patients and individualized chemotherapy based on biomarkers. And that brings an end to my presentation. Thank you for listening.